Welcome to Digital Learning, Department of Collegiate Education. I am Dr. Lakshmi Janardhana, Assistant Professor, Department of Mathematics. In this video, I am going to present you BSc First Semester Mathematics. Let us learn about the chapter Differential Calculus under Calculus 1. Under this chapter, discussing the nth derivative of log of ax plus b and 1 by ax plus b power m. The objectives of this session is to derive nth derivative of log of ax plus b and 1 by ax plus b power n and to solve related examples. By the end of this session, student will able to derive the nth derivative of log of ax plus b and 1 by ax plus b power n and they can solve related examples. Prerequisites. The function has to predefine y is equal to f of x and it has to be differentiable to generate the derivatives. Nth derivative of log of ax plus b. Let us derive the nth derivative of y is equal to log of ax plus b. Differentiating with respect to x, y derivative is y1 and log of ax plus b differentiation is 1 by ax plus b into a. And this to rearrange it, ax plus b power minus 1 into a. To differentiate next time, now here we have to apply differentiation of x power n is n into x to the power of n minus 1. Now we are differentiating y1 with respect to x again. Y2 is equal to minus 1 into ax plus b power minus 2 into a square. Similarly, the third derivative is y3 is equal to minus 1 to minus 2 into ax plus b power minus 3 into a cube and so on to proceed. Yn is equal to minus 1, minus 2, minus 3 so on minus of n minus 1 to a power n into ax plus b power minus n. And here n minus 1 number of negative sign is present to take common factor and that we can write it as minus 1 1 to the power of n minus 1 and remaining term 1 to n minus 1 that denoted as n minus 1 factorial into a power n into ax plus b power minus n. Then finally, nth derivative of log of ax plus b is minus 1 1 to the power of n minus 1 n minus 1 factorial into a power n divided by ax plus b power n. And to solve the related examples, find the nth derivative of log of 1 minus 3x. Let us see the solution. Y is equal to log of 1 minus 3x. Take nth derivative on both the sides. Yn is equal to nth derivative of d power n of log of 1 minus 3x. So it is already in the standard form log of ax plus b. So that standard formula of log of ax plus b, in that just we are substituting only a value here minus 3. Minus 1 out to the power of n minus 1, n minus 1 factorial, a value minus 3 power n divided by 1 minus 3x. Let us see the one more example. Find the nth derivative of log of square root of 2x plus 1 divided by x minus 2. Let y is equal to log of square root of 2x plus 1 divided by x minus 2. To simplify this, here we have to apply the logarithmic property log a power m is equal to m into log a. See m here 1 by 2 into log of 2x plus 1 divided by x minus 2. So again we have to apply one more logarithmic property log a by b, log a minus log b. Log of 2x plus 1 minus log of x minus 2. Now we can apply nth derivative on both the sides. Then nth derivative of first term log of 2x plus 1 a here a value 2 minus 1 1 to the power of n minus 1 n minus 1 factorial into 2 to the power of n divided by 2x plus 1 over n minus the nth derivative of the second term here a value 1 minus 1 1 to the power of n minus 1 n minus 1 factorial 1 to the power of n divided by 1 divided by x minus 2 whole to the power of n. And further, we can do simplification. We can take common factor here, minus 1 whole to the power of n minus 1, n minus 1 factorial. Rest of the term 2 power n divided by 2x plus 1 power n minus 1 divided by x minus 2 power n. One more example. Find the nth derivative of log of x square minus 4. Let y is equal to x squared minus 4. Here we can't apply nth derivative directly. It is not in the standard form. It is a quadratic. It has to be do factorization by applying the formula a square minus b square. Log of x square minus 2 square. So a square minus b square is a minus b into a plus b. Log of x minus 2 into x plus 2. Now again we have to apply one more logarithmic property. Log AB is log A plus log B. Log of x minus 2 plus log of x plus 2. Now we can apply nth derivative on both the sides. Yn is equal to d power n of log of x minus 2 plus log of x plus 2. So the first term nth derivative is minus 1 to the power of n minus 1, n minus 1 factorial. Here a value 1 power n is 1 divided by x minus 2 power n plus nth derivative of the second term minus 1 to the power of n minus 1, n minus 1 factorial. Here also same a value 1 power n is 1 divided by x plus 2 power n. Let us take one more nth derivative of 1 by ax plus b power m. So we already discussed in the previous video session, nth derivative of ax plus b power m is m into m minus 1, m minus 2, so on, m into m minus of n minus 1 into ax plus b power m minus n into a power n. Let m be a negative, say m is equal to minus p, where p is a positive. If you substitute m is equal to minus p in the above expression, then it reduces to yn is equal to nth derivative of 1 by ax plus b power p is equal to minus 1 whole to the power of n, p into p minus 1 to p minus 2, so on, p plus n minus 1 divided by ax plus b power p plus n into a power n. And if you simplify it, it reduces to nth derivative of 1 by ax plus b power p is minus 1 to the power of n, p plus n minus 1 factorial divided by p minus 1 factorial ax plus b whole to the power of p plus n into a power n. And again we have to replace p by m, that finally nth derivative of 1 by ax plus b power m is minus 1 whole to the power of n, m plus n minus 1 factorial divided by m minus 1 factorial into ax plus b power m plus 1 into a power n. Note, if m is equal to 1, the above nth derivative reduces to nth derivative of 1 by ax plus b is equal to minus 1 to the power of n factorial divided by ax plus b whole to the power of n plus 1 into a power n. So related examples, find the nth derivative of 1 by 2x plus 5. Let y is equal to 1 by 2x plus 5. Apply nth derivative on both the sides. Phi n is equal to d power n of 1 by 2x plus 5. See, 1 by 2x plus 5 is already in the standard form of ax plus b. In that standard formula, just we replace it a and b value. And a minus a value here, 2, b value 5. Minus 1 whole to the power of n factorial into a power n is 2 power n divided by 2x plus 5 whole to the power of n plus 1. So let us take one more example. Find the nth derivative of 1 by 5x minus 2 whole to the power of 3. Let y is equal to 1 by 5x minus 2 power 3. Take nth derivative on both the sides. Nth derivative of 1 by 5x minus 2 power 3. This it is in the form of ax plus b power m value here 3 Now we have to substitute in the general formula a, b and m value minus 1 whole to the power of n plus 2 factorial a power n 5 power n divided by m minus 1 factorial is nothing but a 3 minus 1 2 factorial 5x minus 2 power m plus n plus m n plus 3. Find the nth derivative of 1 by 6x square minus 5x plus 5. Let y is equal to 1 by 6x square minus 5x plus 1. Its factor is 2x minus 1 into 3x minus 1. So quadratic term reduces to factorization in the linear factor. Now this denominator linear factor has to separate by applying the partial fraction. 1 by 2x minus 1 into 3x minus 1 is equal to a by 2x minus 1 plus b by 3x minus 1. To take LCM, multiplying by 2x minus 1 into 3x minus 1. If you multiply to numerator left hand side, 2x minus 1, 3x minus 1 get cancelled, get 1. To multiply to a, 2x minus 1 get cancelled, a into 3x minus 1. Multiply to b, 3x minus 1 get cancelled, remaining term b into 2x minus 1. Now here we have to calculate a and b constants. Let us to choose appropriate value of x based on this denominator of a and b. So let us take x is equal to 1 by 2. Left hand side is 1 is equal to a into 3 into a value 1 by 2 minus 1. So b value is 0 here. Then a becomes 2. Put x is equal to 1 by 3. 1 is equal to a is 0. b into 2 into x value 1 by 3 minus 1. Then b value is equal to minus 3. Then ym is equal to nth derivative of a by 2x minus 1 plus b by 3x minus 1. So let us substitute the a value and b value. 2 by 2x minus 1 minus 3 by 3x minus 1. The nth derivative of 1 by 2x minus 1 is minus 1 whole to the power of n factorial divided by 2x minus 1 whole to the power of n plus 1 into a power n is 2 power n minus 3 into n derivative of the second term 1 by 3x minus 1 is minus 1 whole to the power of n factorial divided by 3x minus 1 into whole to the power of n plus 1 into 3 to the power of n. And here you can do further simplification. 2 and 2 power n can write it as 2 to the power of n plus 1, 3 and into 3 power n and write it as 3 power n plus 1. Find the nth derivative of x square divided by x minus 1 whole square into x minus 2. Let y is equal to x square divided by x minus 1 whole square into x minus 2. Here we have to apply partial fraction. The first term is a linear repeated, second term is a linear non-repeated. The partial fraction is a by x minus 1 plus b by x minus 1 whole square plus c by x minus 2. To take LCM, multiplying by x minus 1 whole square into x minus 2. Multiply to left hand side numerator, get cancelled, remaining term x square is equal to multiply to a x minus 1 whole square, one term get cancelled, remaining term x minus 1 into x minus 2. So multiply to b into x minus 2, x minus 1 whole square get cancelled. Multiply to c, x minus 2 get cancelled, remaining term c into x minus 1 whole square. Here we have to calculate the three constants a, b, c. So by choosing the appropriate value of x based on the denominator. Put x is equal to 1. 1 square is 1 is equal to a becomes 0, b into 1 minus 2, then b value becomes minus 1. And anyway c is also 0. Put x is equal to 2. 2 square is 4, left hand side, a becomes 0, b is also 0, c into x 2 minus 1 whole square, c is equal to 4. and remaining one constant have to calculate by equating the coefficient of x square. The coefficient of x square in left hand side is 1 is equal to right hand side first term a, second term is 0, third term is c. Then a is equal to 1 minus c. Anyway, c value 4. 1 minus 4 minus 3 is the a value. So yn is equal to nth derivative of a by x minus 1 is b by x minus 1 whole square plus c by x minus 2. So let us substitute the a, b and c, and nth derivative of 1 by x minus 1 is minus 1 whole to the power of n factorial divided by x minus 1 whole to the power of n minus nth derivative of the second term 1 by x minus 1 whole square is minus 1 whole to the power of n plus 1 factorial divided by x minus 1 whole to the power of n plus 2 plus nth derivative of the third term 1 by x minus 2 is 4 into minus 1 whole to the power of n factorial divided by x minus 2 whole to the power of n plus 1. These are the references we refer to prepare this video. Thank you.